Questions 1 through 10 on the 2019 Grade 12 AMC 12A. The area of a pizza with radius 4 inches is n% larger than the area of a pizza with radius 3 inches. What is the integer closest to n? So obviously pi r squared, where r is 4, and we have to compare that to pi r squared, where r is 3. So that's going to be 16 pi and 9 pi. So we are comparing these. We can drop the pi's and just compare 16 to 9. And 16 over 9 is approximately 1.77. So obviously it's 77% greater. So that would mean E is the closest to N. Suppose that A is 150% of B. What percent of A is 3B? So I'll just use some numbers. Let's say B is 100. A is 150% of B, so it would be 150. 3B would be 300. So compare A. What percent of A is 3B? What percent of A is 3B? Well, to get 3B, we would have to basically multiply A by 2. So 200% of A is 3B. So that would be the answer. Therefore, number 2, the answer is D. A box contains 28 red, 20 green, 19 yellow, 13 blue, 11 white, and 9 black balls. What is the minimum number of balls that must be drawn from the box without replacement to guarantee that at least 15 balls of a single color will be drawn? So we got 28 red, 20 green, 19 yellow, 13 blue, 11 white, and 9 black. So we have to look at extreme case scenarios. Let's say I select all 9 black, all 11 white, all 13 blue, and then I select 14 yellow, 14 green, and 14 red. So far, I have not selected 15 of any color. I'm doing it in an extreme way. Now at this point, the very next ball that I choose will obviously be either red, green, or yellow, since these are exhausted. The very next one will bring one of these up to 15. So for example, if the next ball I choose is green, it would bring that total up to 15, and therefore that would now be the first time that I'm guaranteed. So I've got to add up these numbers: 9, 11, 13, 14, 14, 14, and then that additional one ball that brings it up to 15. So 9 plus 11 plus 13 plus 14 plus 14 plus 14, and then plus that one final ball to bring at least one color up to 15. And when you add up those numbers, it's 76. So number 3, the answer is B. What is the greatest number of consecutive integers whose sum is 45? Well, if you go minus 44, minus 43, and so on, all the way down to minus 2, minus 1, and then you get to 0, and then you start adding the other way, plus 1, plus 2, all the way up until plus 43, plus 44, and then a plus 45. All of these guys, you'll see, cancel out. And the only thing you're left with is 0 and 45. That would, of course, add up to 45. How many numbers is there? Well, these guys, there's 44 of them. There's another 44 of those. So that's 88, 89, and 90. So number 4, the answer is D. Two lines with slopes half and 2 intersect at 2, 2. What is the area of the triangle enclosed by these two lines? And the line x plus y is equal to 10. Well, the first thing is let's create an equation for both of those lines. X over 2 plus b1, and y is equal to 2x plus b2. And then let's use the fact that both of them have 2, 2 to get the b1 and b2 values. So 2 is equal to 1 plus b1, so b1 is equal to 1. So that equation is x over 2 plus 1. Then let's do the same thing, substitute 2, 2 into this one. So we get 2 is equal to 4 plus b2. So b2 is equal to minus 2. So that is y is equal to 2x minus 2. Okay, so let's plot this now. For the first one, we have when x is 0, y is 1. And then when x is 2, y is 2. And therefore, that's about here. So that's the first line. Next one, let's use that equation. When x is 0, y is negative 2. So approximately here, negative 2. And 2, 2, that's the one, of course, that they gave us in the question. So there we go. Now we got to look at that one. That is y is equal to 10 minus x. So let's plot that. When x is 0, we have y is equal to 10, so way up here somewhere. And when x is 1, it'll be exactly 9. So I guess I have to now connect the dots there. And when I do, it will look like this. So that is my shape, that triangle right here, this one. Now, what I noticed with these slopes is that one is 2, one is a half. So that means they're pretty much on either side of the line y equals x. Y equals x, of course, would be the one that's going right down the middle. So like this, right down the middle like that. And therefore, this line would chop that in half. And essentially, it makes it an isosceles triangle. It makes it a little bit easier for us to figure out the area. Okay, so now I've got to figure out some coordinates. This one, and this one is already given. That's just 2, 2. Okay, so this one that we will find with setting 10 minus x equal to x over 2 plus 1. So that means if we multiply through by 2, 20 minus 2x is equal to x plus 2. 3x is equal to 18. X is 6. So this point right here is 6, and then substitute it back into either one of those, and you'll get 4 for the y coordinate. Now that coordinate we get by subbing or setting 10 minus x equal to 2x minus 2. And that would give me 12 is equal to 3x, so x is 4. So that point is 4, 6. Okay, so I can easily get this distance. That's just going to be using the distance formula. 6 minus 4 squared plus 4 minus 6 squared under the square root sign. So that's going to be 4 plus 4, so that's root 8, which is 2 root 2. And then this point is the midpoint of these 2 points. So you use the midpoint formula. 4 plus 6 over 2, 6 plus 4 over 2. And that gives me 5, 5 for this point right there. Okay, the last thing is just to figure out the distance from there to there. That's going to be the height of the triangle. Again, I can use the distance formula. That will be, 5 minus 2 squared plus 5 minus 2 squared under the square root sign. So that's 9 plus 9. And that would be 3 root 2. Okay, finally, we can figure out the area. 1/2 base times height. The base is 2 root 2. The height is 3 root 2. And therefore, this becomes the root 2 times root 2 is 2. That cancels with this 2. And then that would just be 6. So number 7, the answer is C. The figure below shows line L with a regular infinite recurring pattern of squares and line segments. How many of the following 4 kinds of rigid motion transformations of the plane in which this figure is drawn, other than the identity transformation, will transform this figure into itself? So, first let's talk about this statement here. Statement number 1, some rotation around point on the line L. So this is L right here, that line. Well, if you do a rotation, so for example, a 180-degree rotation about a point halfway between an up-facing square and a down-facing square, you'll get the same figure. So this is a point halfway. This is another point halfway, and so on, right? Here's another point halfway between an up-facing square and a down-facing square. And if you rotate it 180 degrees all the way like that, it'll end up being the exact same. So number 1 is fine. Number 2, some translation in the direction parallel to line L. So we're basically going this way or we're going that way. If you translate left or right, you can put the same image onto itself. So you can just realign it. So a translation to the left or right will place the image onto itself when the figures above and below the line realign. The figure goes on indefinitely or infinitely in both directions. So we're going to move this to here, or we're going to move this to here, and it just realigns with itself. So number 2 is correct. Statement 3, the reflection across line L. So what they're saying is that you're treating the line as a mirror. Well, when that happens, this comes up here, and this comes up there. And that, although it may seem similar, it's actually not, because the up-facing squares become down-facing squares and vice versa. So it's not identical. Okay, so that means that one is wrong. That one doesn't work. Okay, so the last one is 4, some reflection across a line perpendicular to y. So now what they're saying is that the mirror is like this. So right down the middle. And at first you might think, yeah, it seems like the squares would be fine. And the answer is yes, the squares would be fine, but notice what happens to these little, whatever they're called, lines, I guess. Those little lines would not be the same. When you reflect it, it would look like that, and that obviously makes a different looking shape, a different looking diagram. The diagonal lines extending from the squares will switch direction, so that doesn't work. So that means of those 4, only 2 will be able to make the figure look exactly like itself, and therefore number 8, the answer is C. Melanie computes the mean, the median, and modes of 365 values that are the dates in the months of 2019. Thus, her data consists of 12 ones, 12 twos, 12 28s, 11 29s, 11 30s, and 7 31s. Let D be the median of the modes. Which of the following statements is true? Well, the mean you can probably easily calculate. 12 times 1, 12 times 2, all that stuff. All the way up until we're going up to 28, right? Because all of them have 12. And then 11 times 29 plus 11 times 30 plus 7 times 30. And then, of course, divide by 365. And when you do all that math, you get it a little bit less than 16, about 15.7. And then the median is what we need to look at next. The median, of course, is the middle value. So there's 365 values. So the median of that would be halfway of 365, which is between the 182nd and the 183rd. Well, if you look at this carefully, there's 12 ones, there's 12 twos, there's 12 threes, and so on, right? So by the time you get up to 15, you will have 12 times 15 numbers. Because there was 12 ones, then 12 twos, then 12 threes, and so on up until you got to 12 15. So each of those had 12. Each of those first 15 numbers had 12. And then this is actually 180. So the 180th number is a 15. And then therefore the 181, 182, and so on would be 16s. So therefore the median is the average of those two, and that's obviously 16. So we got the mean as 15.7, and we got the median to be 16. Now we have to look at the next thing, which is the mode, or actually in particular D, which is the median of the modes. Well, the modes, first of all, are the ones that appear the most, and there's a tie. 1, 2, 3, all those numbers up until 28 all appear 12 times, so there's a tie there. So these are the modes. There's 28 modes. So we want the median of that. Okay, The median of that would be the middle value, which is going to be the average of the 14th and the 15th value. The 14th value is 14 and the 15th value is 15. So the average of that is 14.5. So this represents my D. This what they talk about in the question stem. Okay, so now I have to rank the mean, median, and mode. And to me it looks like 14.5 obviously is less than 15.7, which is less than 16. So D is less than the mean, which is less than the median. So that, in terms of the answer choices for number 12, is E. For a set of 4 distinct lines in a plane, there are exactly n distinct points that lie on 2 or more of the lines. What is the sum of all possible values of n? Okay, so we've got to look at how can I get 4 lines to intersect, yes or no? Well, there's several scenarios. The first is when they're all parallel. And if they're all parallel, the number of intersections, which the question is calling n, is 0. Okay, let's look at the next one. Can we get one intersection with 4 lines? And the answer is yes, if they all kind of have a common intersection point like that. If you draw it like that, you'll get 1. Can I get 2 as the intersection points? And if you fiddle around with this one, you'll find that there's really no way of getting 2, exactly 2. There's 2, but where do I put my third line? If I put my third line here, I get 4. If I put my third line here, I get 3. If I put my third line here, I get 1, 2, 3. If I put my third line here, I get 4. So there's no way of getting 2. So 2, not possible. And that's, I guess, the key to the question right there. The next ones I think are pretty straightforward. You can get 3. I actually probably just showed you that one. How do you get 3? Here's 1, 2, and there's 3. 1, 2, 3. There's a way of drawing 3. And then we can, of course, draw 4. 4, I think I just did. 4 is pretty straightforward. Here's 4. 5 we can get if we have this kind of a scenario. 1, 2, 3, 4, 5. And 6, where everything kind of crosses each other. Let's see here. Something like, that's 3 already. And then if I do that, that'll be 6, right? 1, 2, 3, 4, 5, 6, yeah. So for n, I've got 4, 5, and 6. So I'm going to include this, this, and this for my possible values of n. This one is not possible. So the sum of all the values of n is 1 plus 3 plus 4 plus 5 plus 6, and that is 19. So number 14, the answer is D. A sequence of numbers is defined recursively by a1 equals 1, a2 equals 3 over 7, and an is equal to this expression for all n greater than or equal to 3. Then a 2019 can be written as p over q. What is p plus q? All right, so we got a little bit of math to do here. The first 2 they gave us, so we've got to figure out a3 and so on. And as always with these kinds of questions, your hope is that eventually you'll see some sort of a pattern, and then you can extrapolate that pattern until 2019. All right, so here we go. Let's figure out a3. And remember, we're just using that formula right there, no tricks. That's going to be a1 times a2 over 2 times a1 minus a2. So that's going to be, in our case here, 1 times 3 over 7 times over 2 times 1 minus 3 over 7. And when you do that math, you will get 3 over 11. Now we move to a4. So a4 would be a2 times a3 over 2 times a2 minus a3. Again, using that formula. So a4 is going to be, let's see here, 3 over 7 times 3 over 11 over 2 times 3 over 7 minus 3 over 11. And when you do this math, you crunch out the numbers, you will get 3 over 15. I'm going to leave it as 3 over 15. I'm not going to reduce it for a reason, and that reason will become clear. So let's just keep our tally here, 3 over 11, 3 over 15. Some of you might be able to see a pattern already, but in case you don't, no problem. I'll just keep going, a couple more. A5. A5, of course, will be A3 times A4 over 2 times A3 minus A4. So that's going to be 3 over 11 times 3 over 15 over 2 times 3 over 11 minus A4, which is 3 over 15. And if you crunch out these numbers, you will get 3 over 19. So I think the pattern is pretty evident. And A6 I'll let you do, since it's so much fun. And that comes out to 3 over 23. Okay, so I think at this point you can figure out a pattern. As you can clearly see, every one of these, if you don't reduce it, is a 3 on the numerator, but the denominator seems to be going up by 4. You see that? It's 7, then 11, then 15, then 19, then 23, like that. So we have to come up with a general pattern, and this is something that takes a little bit of practice, but it's going to be, in this case, 7, and then some multiple of 4. And that multiple of 4 in this case is n minus 2. And this is something that you have to figure out on your own. You have to look at this, and it's actually fairly straightforward. I don't want to make this too complicated, but it has to do with an arithmetic sequence. In our case, it was 7, 11, 15, 19, and 23, right? So the general term is a plus n minus 1 d. And where a is the first term, and this is 7, and d is the common difference, which is 4. But the reason it's n minus 2 is because this is the first term, but this is 2. This is the second term, but this is 3. So you have to adjust for that, and that's why it becomes n minus 2. Like that. So, okay, so this is what an is, and what do we have to figure out? A 2019. Okay, no problem. Now that we have a formula, we can just sub in 2019 for the power of n, for the value of n. So when we do, we get 2017 when you subtract 2. So that's 3 over 4 times 2017 is going to be 68 plus 7, 75. So 8075. So this is my P over Q that they keep talking about. This is P over Q. And they want me to find P plus Q. Well, that's 3 plus 8075. And that is 8078. 8078. The answer is E. The figure below shows 13 circles of radius 1 within a larger circle. All the intersections occur at points of tangency. What is the area of the region shaded in the figure inside the large circle but outside all of the circles of radius 1? I'll draw a couple diagrams here, or a couple lines I should say, and hopefully those lines will help. The first is a top to bottom one, like that. And then I'm going to draw lines that actually just go to the center, like this, like that, and then connect that one. So that's going to make a nice triangle, right? Okay. So at this point, let's first figure out a general formula for the area of the shaded region. Area of the shaded region is basically the full area, which is pi r squared, big R, minus 13 of those little ones, so pi small r squared. But small r is just 1, so I can just put that in there. So this is pi r squared minus just 13 pi. The only thing we don't know is the value of big R, which is the radius of the big circle. And that is what this diagram hopefully will help me. This side right here, if I count the radii, 1, 2, 3, 4, 5, 6. So that side has a length of 6. And similarly, the other sides have lengths of 6 because it's equilateral. And because it's equilateral, we know that this will be, if I draw the line down the middle, this will be 60, this will be 90, and then therefore this is 30. So I can use the 30, 60, 90 triangle to get that length. And that length from there to there, I'll just call it h for now. H over 6 is the same as root 3 over 2. So that means h is equal to 6 root 3 over 2. So h is 3 root 3. Now, to figure out the radius of the large circle, I just have to draw in a couple lines to illustrate something called the centroid. And drawn properly, it should match exactly. And the centroid basically is right here, this point right there. And there's a general rule, of course, that some of you may know, that says that if you have a centroid, it cuts that into a 2-to-1 ratio. So this is 2 to 1. So since the whole thing is 3 root 3, from here to here would be 2 root 3, and from here to here would be root 3, because it's got to be a 2-to-1 ratio. So this part is 2 root 3. 2/3 of this, basically. And then from here to here is just 1, since the radii of the small circle. So the big R is that 2 root 3 plus 1. So now I can figure out this fairly easily. It will be pi times 2 root 3 plus 1 all squared minus 13 pi. So that looks like I can factor out a pi, and that's going to give me what? 2 root 3 times 4 times 3, 12, plus 4 root 3 plus 1 minus 13. And that looks like, oh, the 13's cancel, so I'm just got 4 root 3 pi. Yeah, that's it. So that's choice A for number 16.